Hello everyone. So continuing with the chapter light ray recapitulation, we'll learn about what is electromagnetism, and with this class we'll conclude this chapter. So electromagnetic wave is a combination of electric and magnetic waves. So here we can find out very clearly the y-axis is representing the electric field, the wave on the y-axis is representing electric field, and the wave on x-axis is representing the electric field, magnetic field. So in this way, combination of two waves, we are getting the electromagnetic wave. That is, we find as a part of the chapter. So electromagnetic waves originate from the vibration of charged particles. There are many waves, but the special property of this wave is that these are produced because of the vibration of the charged particles. Any wave is produced because of the vibration, but these waves are produced. These electromagnetic waves are produced by the vibration of charged particles. So the keyword you can understand and remember here is vibration of charged particles. And these waves do not require any medium as such, as similar to light waves. And the higher frequency of the vibration gives the higher energy, and shorter is the wavelength of the electromagnetic wave. And the vast range of this frequency is described in the electromagnetic spectrum. So we know what is this electromagnetic spectrum. So this is a broad spectrum which is representing all different waves, X-rays, gamma rays, ultraviolet rays, infra, micro, radio, and so on. So on top left, if you see here, the frequency range or the energy level increasing, both are representing towards left. So the left is the direction of left is representing the increasing frequency level or the energy level, and towards the right we can see the increasing wavelength. So from this picture or the image, you can clearly distinguish how the radio waves are having the largest wavelength, and the gamma rays are having the shortest wavelength. But although they are having shortest wavelength, the gamma rays carry the maximum energy. The energy level is very high for the gamma rays, whereas the energy level is very less for the radio waves. And all the rest of the rays fall between these two rays, within these two rays spectrum. And we will see their applications now. The radio waves, their application is very visible, clearly visible to us. They are used for communication purpose, especially in the communication media. It can be in terms of television or radio or network system. All these applications are based on these radio waves, which are the part of the electromagnetic waves, part of the electromagnetic spectrum, and the microwaves. Next, here these are the waves which are having less wavelength compared to radio waves, but little more energy compared to radio waves. And here the food is being cooked by placing the food inside the microwave oven, because the microwaves have the ability to penetrate more than the radio waves. So in these terms, these microwaves are a little harmful compared to radio waves. And if you go a little further, we have a visible spectrum here. But before visible spectrum, we have infrared rays. So these infrared rays are accompanied by any heat source. Without heat, we cannot find or we cannot get this infrared rays in natural conditioning, but artificially we can do anything. So these infrared rays we use in order to control systems like remote controls in terms of any appliance like TV or refrigerator sometimes, or even AC, And then comes the visual spectrum. This is the only spectrum, visual spectrum, which is visible to our naked eye. Rest of the rays like micro radio or X-ray or gamma rays, these are invisible light rays, invisible rays. They are not light rays. So next, moving on to X-rays. These X-rays have little more penetrating capacity, ability compared to micro and radio on the right. So therefore, because of this penetrating ability, the application we are using it as that these rays, although they are invisible, they can penetrate to our skin, flesh, muscle, but the penetrating ability of the lower spectrum of this X-rays is used for this X-ray purpose, which don't penetrate through the bones. So the area where the bones, the area where the wave is not being penetrated is captured as the image as shown here. Then going further, gamma rays. These gamma rays are having much more energy compared to this X-rays. So therefore, they can not only penetrate through skin or something, skin muscle. They can also penetrate to bone and even metals. So they are definitely harmful. But we can also use them for right purpose, like killing the harmful cells in our body, cancer cells. So no, not only gamma rays, even X-rays is also being used for the same purpose. So we've discussed all these things, but they are having just a fast quick recapitulation about this. So the last aspect is the communications. So whatever the medium of communication may be, it can be telephone, radio, or TV, say, anything, cellular, mobile, even internet. All forms of telecommunication are carrying or transmitting information either by sounds or pictures or data. Fundamentally, in communication, mm, there are two systems that have been applied by two appliances. One is encoder and the other is decoder. We'll see what is encoder and decoder, then I'll come back to the slide. Here you can see the transmitter and the receiver. Here at the transmitter, the data is being transmitted by converting either from sound or light or the fundamental input data. Here just mention it converts incoming information like sound pictures, just what I dictated before, into a form which can be transmitted. That is electrical. Because once you get electrical signal, we can transmit over long distance. So fundamentally, encoder what it does is it converts the input signal, either sound or picture or data, into electrical signal. This is at first aspect of the communication. And once the transmission is being done in the form of electrical signal, then the decoder is used. It turns the signals back into useful information, again back into the original data, that is either sound or picture, whatever the requirement is accordingly. So this encoder, how it converts the sound signals, pictures into electrical, how this is being done, we'll see here. That is from analog to digital conversion. Here is a simple example how the data in the form of sine wave, either it can be sound or light, you can have it in the form of sine wave. So here is the sine wave showing the slide. It is divided into digital conversions in the binary form by taking the sound values of the signal values in the form of zeros and ones. Here's the sequence how the data is being encoded from analog to digital. This is a further expansion where y-axis is representing voltage and x-axis is representing time, because the voltage is representing voltage on y-axis is representing the magnitude of the signal that is being carried. And physically, if you see the circuit, this is how the circuit appears, wherein there are different gate systems which are going to learn in the stage 10 upcoming chapters, digital electronics. So here is the view of few gates here. So with the combination of these gates, from the left hand side you are giving the input as analog signal, and on the right hand side you have here B1 and B2 where you get the information or the data in the form of digital signals, that is zeros and one binary. And this is the overview of the whole thing, what is happening. Antenna which transmits the signals, and through the in the form of radio waves. Here in this example, the waves are being transmitted, and there is at the receiver there is one more antenna which receives the signals. So there are fundamentally two antennas: antenna at the transmitter, antenna at the receiver. So this is how the communication is being done, and this is a overview of the explanation from analog to digital conversion. And advantages of this digital transmission is the point to be noted here. To restore the quality and the power of the signal wave, they can be cleaned and amplified. That means the digital signal, although it is having some noise into it, it can be easily cleaned in terms of digital form. Whereas in the analog form, we cannot do it. The reason is the data is inbuilt with the noise. In digital transmission, the actual data can be even amplified later. Therefore, the second point to be noted is they won't amplify the noise along with the noise. That means the digital data that we get from the analog, in analog form, the noise is also amplified along with the data. But in digital transmission, the digital signal, noise is not amplified, only the data that we are in need of is amplified. Noise is not at all amplified. And other thing is the quality of the signal is much better, very good compared to the analog signal. So because of these advantages, we prefer digital transmission than the analog, because analog carries a lot of noise along with the data. So noise represents not only in sound form noise, but also addition of any other waves. It can be light waves, or it can be noise, or it can be even fluctuation of the display. So all these are nothing but the additional of the external unwanted signals. Applications, here these are the applications we find. That is optical fibers is the main application based on which the communication is being communicated all over the world. And here are few videos I have included in the PPT. So I'll forward this so that you can go through these videos and understand about the communication. So go through this cellular communication. It's really good. The second point is representing here about cellular communication. We'll actually know how the communication is being done. I'll just